Hi Math 2. This is our Unit 7 Unit Circle Part 2, a continuation of the work we were doing last week. So in our class, we've talked about the sine function, the cosine function, and the tangent function, and their abbreviations for sine, cosine, and tangent. There's three more trig functions that we need to be familiar with. Those are cosecant, secant, and cotangent. They also have abbreviations. For example, when I see the CSC, I would say cosecant theta. SEC is my secant theta, and COT is how we abbreviate cotangent theta. My cosecant theta is equal to 1 over sine theta. My secant theta is equal to 1 over cosine theta. One way to keep those straight is, remember, it's C and an S, but the C doesn't go to C and the S doesn't go to the S. So cosecant goes to 1 over sine and secant goes to 1 over cosine. And then cotangent is equal to 1 over tangent. And cotangent theta, so let's think about our tangent theta for a moment. Tangent theta is our opposite over our adjacent, which is our y over our x in our unit circle. That's sine theta divided by cosine theta. So cotangent theta is 1 over tangent theta. But we more often think about it as, instead of sine over cosine, we think about it as the flip-flop, cosine theta over sine theta. It's still 1 over tangent theta. It's still the flip-flop of tangent, but we think of it in terms of cosine and sine. So let's look at why we do that. We've learned that sine theta is equivalent to the y coordinate from our unit circle. Cosine theta is equivalent to our adjacent side, the x coordinate, and tangent theta is my opposite over my adjacent, or my y over my x. So we use those same coordinates for these three trig functions. Cosecant theta is 1 over sine. Since sine is y, it means cosecant is 1 over y. Secant theta is 1 over cosine, and since cosine is x, it makes secant theta 1 over x. And cotangent theta then is x over y, which you'll remember is the reverse of tangent theta. So how do I use these to help me find values for my unit circle? Let's take 30 degrees. So go to your unit circle from last week and find me the coordinate that goes with 30 degrees. You should have 3, square root of 3 over 2, 1/2. And 30 degrees is pi over 6 radians. So last week we learned that my sine theta is my y. So the sine of 30 degrees is 1/2. Cosine theta is my x. So the cosine of theta is rad 3 over 2. And tangent theta, and I'm going to write in the space above, tangent of 30 degrees is my y over my x. It's 1/2 divided by rad 3 over 2. Well, we learned, or I guess remembered from grade school, when you're dividing fractions, it's the same as multiplying by the reciprocal. So this is really 1/2 times 2 over the square root of 3. My 2's cancel, and I get 1 over the square root of 3. But earlier this year, we learned that to have a square root in the denominator is not simplified. So we would rationalize the denominator by multiplying both the numerator and denominator by the square root of 3. And my numerator becomes the square root of 3, and conveniently my denominator, which is now the square root of 9, which I can do is 3. There's no more square root in my denominator. So the tangent of 30 degrees is the square root of 3 over 3. So now let's work on the cosecant of 30 degrees. Well, cosecant, I just learned that cosecant of theta, or in this case it's 30 degrees, would be 1 over my y value. So 1 over my y value is 1 over 1/2. So that's the same thing as 1 times. So instead of dividing by 1/2, I'm multiplying by the reciprocal. When I flip my 1/2, I get 2. So this is the same thing as 1 times 2, or 2 is what my cosecant of 30 degrees would be. So let's take a look at what secant of 30 degrees would be. So secant of 30 degrees is 1 over my x-coordinate. My x-coordinate is rad 3 over 2. So this becomes 1 times the reciprocal of my denominator, so 2 over rad 3. And so this is 1 over 1. So this becomes 2 over rad 3. Now there's a problem with that answer. The problem is my square root in the denominator. So let's multiply both the top and the bottom by my square root so it cancels. My numerator is 2 times the square root of 3. Don't multiply those. One's an integer, one's a square root. There's no square root of 6 here. You cannot combine them in any way. It's 2 rad 3. And the denominator, they're both square roots, so I can multiply them. I get the square root of 9, which is 3. And that would be my answer. There's nothing to cancel here. The 2 and the 3 are my integers, and I can't simplify them anymore. So this would just be 2 rad 3 all over 3. Now cotangent would be x over y. So in this case, the cotangent of 30 would be 3 rad 2 over 2. That's my x divided by my y, which is 1/2. So this is rad 3 over 2 times the reciprocal of 1/2, which is 2 over 1. The 2's cancel, and then I just get rad 3 over 1, or rad 3 for cotangent theta. So let's also review what happens when I have a coordinate such as 0 and -1. Let's take a look at 270 degrees. The coordinates at 270 degrees is 0, -1 from my unit circle. And so the radian angle at 270 degrees is 3 pi over 2. So my sine would be my y value, -1. My cosine is my x-coordinate, that's 0. My tangent is equal to my y value over my x value, so -1 divided by 0, which is undefined. We cannot divide by 0. My cosecant is 1 over my y value, which is 1 over -1. 1 divided by -1 is -1. Secant theta is 1 over my x-coordinate, so that's 1 over 0, which again is undefined. And then my cotangent is my x over my y value. So this would be my 0 over -1, which is fine. You can divide 0 by other numbers, but the answer is always 0. So 0 divided by -1 is 0. So the rest of this chart is yours to fill in. And then let's double check our answers in Google Classroom and bring any of those questions to our Tuesday, Wednesday Zoom on how to get values from our unit circle for our new cosecant, secant, and cotangent values. So another topic we're going to be discussing this week is the sine, cosine, and tangent graphs. So I'm going to fill in this table for theta and my y values. Theta is my x-axis here. So if you look at this axis, this is my theta axis, not really the x-axis in this case. And the values that I have here are pi over 2, pi, 3 pi over 2, and 2 pi, and 0. Notice that they are the values that are in the theta column of my chart. So now I also have y values that I'm going to find. My y value is equal to sine theta. So I need to calculate the sine of each one of these thetas. So again, I'm going to use my unit circle. I'm looking for the sine of 0. So if I substitute a 0 in for my theta, I'm trying to find the sine of 0. So go to your unit circle. The sine of 0 degrees is 0. Now I'm trying to find, let's substitute pi over 2 in for my theta. Sine of pi over 2, sine of my 90 degrees is 1. And then continuing around my unit circle, my sine of pi is back to 0. My sine of 3 pi over 2, my sine of 270 degrees is negative 1. And my sine of 2 pi is back to 0. So this is 5 coordinates to plot on my graph. My first coordinate is 0, 0. So plotting my first coordinate, 0, 0. My next coordinate is pi over 2, 1. So let's go to pi over 2. To give myself some space, I'm actually going to let 1 unit be 2 squares, just so I can have some space on my graph, not so scrunchy. So pi over 2 would be my first coordinate, like my x coordinate, and then my 1 is my y coordinate. Now I'm back at pi comma 0, or pi 0 on my graph. The next coordinate is at 3 pi over 2 in the theta direction and negative 1 in the y direction. My next coordinate then is 2 pi 0. And these can be written like coordinates. This is 3 pi over 2, comma, negative 1. And that's what I've plotted. So in order to connect these 5 points, we have to use a curve. You want this to not be linear. This is a curve. So it's almost like an upside down bowl for this top part, going up from 0, 0 to pi over 2, 1, and then back down to pi 0. And now we're going to curve the other way. And so this really looks like 2 upside down bowls, curved down on top here and curved up on the bottom. This is my sine graph. So when we deal with trig functions, we have something called a period. The period is the distance to complete one cycle. And what you're looking at is one cycle of the sine graph. You started at 0, 0, you went up to 1, back to 0, 0, down to negative 1, and then back to 0, 0. Highlighting our movements. My period, it was from 0, 0 up to 1, back to 0, 0, from 0, 0 down to negative 1, and then from negative 1 back up to 0. So in this case, my period then is 2 pi, and I'm getting that from my theta axis. I did one total cycle from 0, 0 back to this 0, 0, one total cycle in 2 pi units on the theta axis, our x-axis. Amplitude is distance. It's how high above and below our midline that your graph goes. So amplitude, in this case, I went up 1 unit above my midline. My midline, the line in the middle of my graph, is the theta axis, the pink theta axis. And here I went 1 unit below. So it's a distance, so it's not negative. So my amplitude here is basically 1 unit. I go up 1 unit, I go below it 1 unit, but my entire curve is somewhere from 1 unit above to 1 unit below my midline. And the midline is the line that goes through the middle of my graph. In this case, it was my theta axis, which is where my x-axis is. That's the line y equals 0. So this graph, sine graph, we'll talk about in our Zoom, but it continues on. This is a cyclical curve. So what you're looking at is one cycle of it, one portion of it between 0 and 2 pi. So let's take a look at our cosine graph. Our cosine graph, let's fill in our cosine table, again from our unit circle. My x coordinate, if you will, is my, oops, sorry, I thought I was on my highlighter. My x coordinate, if you will, is my theta. That's my theta axis. So this is my theta coordinate. and I'm going to calculate my y value. So let's look at my unit circle and find the cosine of 0 degrees, which is 1. I'm looking at my x coordinate. The cosine of pi over 2, the x coordinate, is 0. The cosine of pi, the x coordinate's negative 1. The cosine of 3 pi over 2, the x coordinate, is 0. And the cosine of 2 pi, my x coordinate, is 1. So I'm going to plot these 5 coordinates. So 0, 1, 0, 1, 0 in the theta direction, up 1. Now pi over 2, 0. So pi over 2 in the x or in the theta direction, and no up or down. Pi negative 1 in my graph. And then 3 pi over 2, I'm back to 0 in the y direction. And then finally 2 pi, I'm back to 1. So now I'm also going to connect these with a soft curve. So from 1 down to pi over 2, it's a downwards, concave down type curve. Looks like half of a bowl, upside down bowl. So now I'm going to turn my curve. I'm going to change, if you will, we call it my concavity. It's now going to look like a right side up bowl. So I'm going to come down towards this and then back up to my theta axis. It looks like a bowl that could hold milk. And now I'm going to do the other half of the upside down bowl. And this is what we consider one cycle of cosine. I start at 0, 1, and notice down here I'm ending at 2 pi, back up at 1. I've traveled from 1, this height of 1, to my x-axis, theta axis, below my theta axis to this pi negative 1, back up to my theta axis, and I end where I started at 0, 1, but at 2 pi 1. So this is considered one period for the cosine graph, and it starts at 0 and it finishes again at 2 pi. That's one cycle, because this graph actually does continue after these 2 points, and we'll talk about that in Zoom. My amplitude is the distance above and below my midline, and so this had a height of 1 above. This has a height below of 1, and again a height of 1 above. It looks like my amplitude in this case is 1 unit above or below my midline. And my midline again is the theta axis, which is my x-axis, and that's the line y equals 0. So let's take a look at our tangent graph. We're going to fill in our table just like we did for sine and cosine. So when theta is 0, my tangent was 0. When theta is pi over 2, my tangent is undefined. When theta is pi, my tangent was 0. When theta is 3 pi over 2, my tangent is undefined. And when theta is 2 pi, my tangent is 0. You can find those values again by using your unit circle. Remember, tangent is opposite over hypotenuse. It's your y coordinate divided by your x coordinate. Or you already did this work on the table in the front of this worksheet. If you go back to that, you can find the tangent for each one of these thetas. So now we have to be able to plot the undefined. It's really an asymptote in our graph. It's a place that our graph doesn't exist. So I'm actually going to go to my graph, and I'm going to put a vertical dotted line at pi over 2 and at 3 pi over 2. This vertical dotted line is not part of my graph. However, it's a place for me to visually know that I should not cross that line. My graph doesn't exist at those 2 theta values because it's undefined at those 2 theta values. So I want to make sure that I don't draw there. So those dotted lines help me. So then back to my sketch of my graph. So in this graph, if I plot a few more points, if you go to your graph and you plot halfway between 0 and pi over 2 is pi over 4, you'll see that tangent at pi over 4, so tangent at 45 degrees, is actually equal to 1. So let's call this 1 again. So that gives me a coordinate right about in here. And so this graph at 0, it's 0, 0 is my first coordinate, and then at pi over 2 it's undefined. So my graph goes through these points, and then it goes right up to my asymptote, and then continues straight up forever. I put an arrow there. It never ever crosses my asymptote. It's not defined there. So my next coordinate is pi 0. So at pi, my y value is 0. What is it doing at either side of pi? So let's use my unit circle. Some values on either side of pi. In the second quadrant, I have 3 pi over 4. And in the third quadrant, I have 5 pi over 4 that come right before 3 pi over 2, 270 degrees. And I notice that at 3 pi over 4, if I look at my chart, my tangent's -1. So I know that my coordinate's down here. And at 5 pi over 4, I notice that my tangent is +1. So this creates a curve. This curve is concave down, or points down to go through that point, and then runs alongside the asymptote, doesn't cross it. And then it's curved up, it moves upwards, up above, and cruises right along my asymptote, but doesn't cross it. And then lastly, according to my table, I have the coordinate 2 pi 0 on my graph. So it'd be nice to know what it was doing between 270 degrees, because this is my 90 degree pi over 2, this was my 180, this is my 270, and then this is 360. It'd be nice to know what it's doing between 270 and 360 degrees. So if you go, for example, I could use any coordinate I want in the any theta I want in the fourth quadrant, but why don't we use the one smack dab in the middle, 7 pi over 4. You'll see at 7 pi over 4, I'm at -1. So I know that at this portion of my graph, tangent is a downwards pointing graph that's like this. Really, if we continued this on, we would see that when we go past theta 0 into negative thetas, my graph is something like this. And my graph continues after as well. But what you're really looking at is just the unit circle values for tangent. So in this one, we have 2 asymptotes. The 2 asymptotes are from our unit circle. This is where the function is undefined, doesn't exist. We don't draw our graph there. In this case, the tangent period is actually pi units. It creates an entire cycle from pi over 2 to 3 pi over 2, which is really just pi units. It's pi units between those two. And so actually, what I've kind of drawn in here would be 3 periods of tangent is what you see there. You see the 3 different curves. In between each asymptote is a period of the tangent graph. So the period would be pi. At this point, if you want to take a break, this would be a good time to take a break and then come back and finish off your notes for graphing transformations of the sine and cosine graphs. So let's look at the general form of the sine function. It's y equals a sine b of theta plus h in parentheses plus k. And the general form of the cosine function is y equals a cosine b theta plus h in parentheses plus k. For our class this year, we're going to mainly look at what happens when I change the values of a and k. Next year in your course, you'll look at what happens when you change the values of b and h. Theta is my variable, so the theta isn't a value that you change. What are the purpose? What's the role of the different parts of my equation? Well, the A is my amplitude. So the A tells me the distance above and below the midline. So now H is the horizontal shift. H is the horizontal shift, and we won't be dealing with H this year, but just so you know, it behaves the same way it did for quadratics. It behaves the opposite of what you see inside parentheses. So your shift left or right would be the opposite of really what you see there. K is my vertical shift. We'll be doing this. K is your vertical shift. And just like last year, it behaves normal. It behaves just like what you see. If your value is a negative, like a -3, it means your graph is going down, shifting down. If your value for K is a positive number, your graph shifts up. This basically changes my midline. So this is how I shift my graph. B helps me find the period. The period can be determined by 2 pi divided by B. We won't really be looking at B this year in class, but in Zoom we will look at the effect of shortening or lengthening the period, what it does to our wave. So let's take a look at the sine wave. Let's take a look at 2 sine theta. This 2 out in front is in place of my A. In other words, my amplitude in this case is going to be 2 instead of 1. So let's think about what this graph looked like without the 2. So if you flip your page back over, my graph looked like it started, if this was 1, and if this was -1 from the front side, my graph started at 0, 0. It went up to a height of 1, back to the theta axis, down to -1, and back to the theta axis. So on the front side, this graph, the basic sine graph, looks something like this curve. So now I'm changing that. I'm changing my amplitude to 2. This is really y equals a sine theta. My a is 2. So I'm basically going to double the height above my midline. So this is going to go up to a height of 2 above my midline instead of 1, and down to the height of -2, or a height of 2, but down to -2 under my midline. I'm still going to have 0, 0. I'm still going to have pi 0. I'm still going to have 2 pi 0 on my graph. I haven't changed where my midline is. I've changed how high and above and below my graph is going to be. I've doubled the height. So this is connecting them now with my downwards. Remember, it's not linear. Don't make it look too pointy. Make sure it looks like a curve. Just a very tall bowl in this case, like bowl above, pointed down, and below. This would be a sine graph. This one is basically the amplitude was changed. And so it's a height of 2 above and 2 below my midline. That's what the A does. So what does the K do? Let's take a look at this next one. This is really y equals cosine theta plus a k. In this case, my k is 1. I have a vertical shift of +1. What is that doing? It's shifting my entire graph up 1. So my graph gets shifted up 1. This is my new midline. So this is my new 0, if you will. Let's pause for a minute and look at what the graph looks like on the front of our worksheet. So if I could lightly shade that in, it started at 0, 1. I came back down to the pi over 2, 0. I went past that. I came down to pi -1, went back up to my midline, and I finished at 2 pi 1. This is the shape of the graph from the front of our worksheet for cosine. So I'm basically going to take that graph and I'm going to shift the entire graph up 1 unit. So instead of being at 0, 1, I'm really at 0, 2. I'm shifting everything up 1. Instead of being at pi over 2, 0, I'm really at pi over 2, 1. Instead of being at pi negative 1, I'm really at pi 0. I've just shifted all my y values up 1 from the table on the other side. So 3 pi over 2, 0 becomes 3 pi over 2, 1. And 2 pi, 1 becomes 2 pi, 2. I've just shifted all my values up 1 unit, all my y values. And I pencil in the same graph, concave down as I come down towards my midline. Now I have the bowl that's concave up. And then I go back to my half a bowl that's concave down. This is my entire cosine graph shifted up 1 unit. So let's fill in. I just realized we hadn't been filling in some of the things at the side. Going back to number 1, the period is 2 pi. It's 1 complete cycle of sine. My domain is my theta axis, my x-axis. The way I've drawn it, it includes 0 and goes all the way to 2 pi, including 2 pi. That's why I have brackets. The range is my y values. These are my x values. The range is my y values. This particular graph goes from -2, it's my lowest y value, to +2 is my greatest y value. And there was no vertical shift. You could put a 0 there, non-applicable, just draw a line, no vertical shift. So this graph, my vertical shift was +1. My amplitude is just 1. I can see that in 2 ways. In front of my cosine is nothing. I know then there's just a 1 there. So my amplitude is just the regular 1. My period is 2 pi. My entire graph goes from 0 to 2 pi on the theta axis. My domain then, my x value shown in this graph is 0 to 2 pi. My theta value shown in the graph, sorry. This is my x theta in this case, theta in this case. And the range is my y values. Now be careful here. Your y values now, your lowest y value is 0. And your greatest y value is 2. So my range changed because my vertical shift changed. Just like in the first one, my range changed because my amplitude changed, the y values changed. So let's continue with one more example. This example has another vertical shift. This is really y. This is really y equals a sine theta plus k. So my a is 1. So my amplitude hasn't changed. There's no number in front of my sine. However, I do have a -1. This means my vertical shift of my entire sine graph is going to be down 1. So I'm going to pencil my sine graph from the front side. Remember, sine started at 0, 0. It goes up to 1, and then it comes back to my midline, then goes 1 below my midline, and then back up to my midline. So that's my sine graph from the front of my worksheet. So now I'm going to shift everything down 1 unit. My entire midline is going to shift down 1. So I'm down here at -1. This is my new midline. Everything is going to come down 1 unit in the y direction. So let's plot some of those points. So instead of being at 0, 0, I'm going to shift down 1. I'm at 0, -1. Instead of being at pi over 2, 1, I'm going to shift down 1 and be at pi over 2, 0. Instead of being at pi 0, I'm going to shift down 1 and be at pi -1. Instead of being at 3 pi over 2, -1, I'm now going to be at 3 pi over 2, -2. And then instead of being at 2 pi 0, I'm going to be at 2 pi -1. I just shifted all my y values from the table on the front side down 1. And now I'm going to pencil in my upside down bowl, my concave down part of my curve, and then I'm going to have my right side up bowl, which is my concave up part of my curve. This part of my curve is considered concave up. That's my concavity. Those of you who are contact lenses, that's my contact lens pointed up. And then this would be my concave down portion of my graph. That's where my curve is pointing downwards. So then this would be an example of having a k of -1 for sine. My period is still 2 pi. The entire curve takes place from 0 to 2 pi on the theta axis. My domain goes from, in this particular case, my theta values go from 0 to 2 pi. My range now, my lowest y value is -2. And my highest y value is 0. They're included, I'm going to use brackets. And then my vertical shift, of course, was -1. Thank you.